Hi there. This interview is about how systems fail in real life, not all at once, but partially. Some users are broken. Some features are slow. Dashboards look fine. Customers are angry. That gap is where strong DevOps and SRE judgment shows up. I want you to pause the video after each question, answer it out loud as if you were in a real interview, then compare your thinking with a strong sample response. If this style helps you think more clearly under pressure, subscribe so you do not miss the next interview. Let's start simple. Tell me about a time you were dealing with an incident where the system was not fully down, but users were clearly impacted. A strong answer here usually starts by acknowledging that partial outages are harder than full outages. I would explain that in one incident, core APIs were up, but latency was high for a subset of users. The challenge was that alerts were not firing because error rates stayed low. I focused first on validating user reports, checking request latency by region and endpoint, and then narrowing the blast radius. I would emphasize communication, setting expectations early, and resisting the urge to declare success just because nothing was fully read. Next question. How do you decide when something is an incident versus just noise or minor degradation? A solid response sounds calm and practical. I would say I look at user impact first, not metrics. If users cannot complete critical actions or are experiencing noticeable delays, it is an incident, even if the system is technically up. I also consider trend direction. A slow but steadily worsening system is more dangerous than a brief spike. I make the call early and downgrade later if needed, because delayed response usually costs more than a false alarm. Another one. Tell me about a time you had to communicate uncertainty during an outage. A strong candidate does not pretend certainty. I would explain that I was upfront about what we knew and what we did not. I shared hypotheses, next steps, and update intervals instead of guesses. That built trust with stakeholders and reduced pressure on engineers to rush risky fixes. I would also mention that I kept updates boring and predictable, which actually calmed people down. One more behavioral question. What is your role during an incident when you are not the primary responder? A good answer shows maturity. I would say my role is to reduce load on the responder. That means handling communication, documenting timelines, or validating fixes in parallel. I avoid jumping into changes unless asked, because too many hands can slow things down. The goal is to make the system and the humans more stable at the same time. Now let's move into technical judgment. Imagine users report that checkout is slow, but only on mobile and only in one region. Error rates are normal. Where do you start? I would start by validating the scope. Mobile versus desktop suggests either a client difference or a back-end path specific to mobile. One region points toward networking, CDN, or a regional dependency. I would check latency percentiles rather than averages, broken down by region, device type, and endpoint. If the issue is real, I would look for a dependency that mobile traffic hits more often, such as a feature flag service, third-party API, or image service. I am not trying to fix yet. I am trying to understand the shape of the problem. Next question. What are degraded modes, and why are they important? I would explain that degraded modes are intentional ways a system continues operating when some components are unhealthy. Instead of failing completely, the system sheds non-critical features, serves cached data, or limits functionality. They matter because users often prefer a reduced experience over no experience. Designing degraded modes forces you to think about what actually matters during stress, and it turns unknown failures into predictable behavior. Let's go deeper. How would you design a service to degrade gracefully when a downstream dependency is slow? I would start by protecting the service itself. That means timeouts, circuit breakers, and bulkheads, so one slow dependency does not exhaust all resources. Then I would define a fallback. That could be cached responses, stale data, default values, or skipping optional work. I would make these behaviors explicit and observable, so we know when we are in a degraded state. Finally, I would test these paths regularly because untested fallbacks tend to fail when you need them most. Another scenario, your dashboards show everything green, but support tickets are increasing. What do you suspect? I would suspect blind spots in our observability. Green dashboards often mean we are measuring the wrong things. I would look for missing signals like tail latency, user journey success rates, or regional breakdowns. I would also question alert thresholds. If alerts are based on averages, partial pain gets hidden. At this stage, I trust users more than dashboards and treat their reports as signals we failed to capture. One last question for this section. How do feature flags help with partial outages? Feature flags give you control over blast radius. They let you disable or degrade specific functionality without redeploying. In partial outages, that speed matters. You can turn off a problematic feature for affected users, regions, or platforms while keeping the rest of the system usable. The key is discipline. Flags need ownership, documentation, and cleanup, or they become another source of failure instead of a safety tool. We will continue from here and push deeper into trade-offs, pressure decisions, and uncomfortable gray areas in the next section. Let's keep going and push deeper into the uncomfortable parts of partial outages. Imagine a downstream service starts timing out intermittently, not failing completely, just slow enough to cause retries. CPU is climbing, but nothing has crashed yet. What do you do first? The first thing I do is slow the system down on purpose. Intermittent timeouts plus retries are a classic amplification problem. Every retry adds more load and makes the system less stable. I would check timeout values, retry policies, and concurrency limits. If retries are aggressive, I would reduce them or disable them temporarily. Then I would add or tighten timeouts so requests fail fast instead of piling up. The goal is to stop the spiral before thinking about root cause. Once the system is stable, then I can investigate why the dependency is slow. Next scenario. Your service depends on a database that is healthy but under heavy load. Read latency is creeping up. Writes are fine. What degraded mode would you consider? I would first identify which reads are actually critical. Not all reads deserve the same priority. For non-critical reads, I might serve cached or stale data. If caching already exists, I would increase cache TTLs to reduce pressure. If caching does not exist, I might temporarily disable features that trigger expensive reads. I would also consider rate limiting certain endpoints or user actions. The trade-off here is freshness versus availability. Users usually tolerate slightly stale data better than slow or broken experiences. Another question, how do you detect partial outages when alerts are not firing? I rely on signals that represent user experience rather than system health. That means things like request latency percentiles, success rates for key flows, and synthetic checks that mimic real user behavior. I also pay attention to changes in patterns rather than absolute thresholds. A sudden increase in support tickets, retries, or client-side timeouts is often the first sign. Partial outages live in the gaps between metrics, so you need multiple perspectives to see them. Let's make it harder. You have a feature that depends on 3 services. One of them is flaky. Do you disable the whole feature or try to degrade it? My default is to degrade first, disable second. I ask what value the feature still provides if part of it is missing. Can it work with reduced accuracy, slower updates, or fewer options? If degradation keeps the system stable and users can still complete their main tasks, that is usually the better choice. I disable the feature only if the degraded version causes confusion, incorrect data, or more load. The risk with degradation is hidden failure. If users cannot tell something is wrong but get bad results, that can be worse than a clear outage. Another scenario, how do circuit breakers help in partial outages and what can go wrong with them? Circuit breakers prevent a struggling dependency from dragging everything down. When failures cross a threshold, the breaker opens and stops traffic for a while. This gives the dependency time to recover and protects upstream services. What can go wrong is poor tuning. If thresholds are too sensitive, breakers flap and cause instability. If they are too loose, they open too late and damage is already done. Also, if fallback behavior is not well designed, opening a circuit can create a different kind of outage. Circuit breakers only work well when combined with meaningful fallbacks. One last question in this section. How do you test degraded modes before you need them? I prefer controlled failure over surprise failure. That means running game days, fault injection, or chaos experiments in non-production and sometimes production environments. I test what happens when dependencies are slow, not just down. I observe whether alerts fire, whether dashboards make sense, and whether people know what to do. The biggest value is not the technical result, but the learning. You find missing runbooks, unclear ownership, and unsafe assumptions long before a real incident forces those lessons on you. That is the core of partial outages and degraded modes. Nothing is clean. Nothing is binary. The strongest engineers are the ones who can reason clearly in that gray space. Let's switch gears. These are the kinds of questions where there is no clean answer and no perfect metric to guide you. Imagine you are in an incident call. Some users are complaining loudly. Metrics look mostly fine. Leadership is asking whether to declare a full incident. What do you do? I slow the room down. Declaring an incident is not about ego or fear. It is about coordination. If users are impacted and the team is already multitasking or guessing, I would lean toward declaring. Even if metrics are green, user trust is already damaged. Declaring an incident creates structure. Roles get assigned. Communication becomes clearer. The risk of overreacting is usually lower than the risk of underreacting. I can always downgrade later, but I cannot get back lost time and focus. Next scenario. You have a degraded mode that keeps the system alive but delivers a noticeably worse experience. Some teammates want to keep it on to avoid downtime. Others want to turn it off and fix the root cause faster. What do you choose? I would first separate two timelines in my head, the now and the later. For now, my priority is user safety and system stability. If degraded mode is stable and predictable, I keep it on. That buys us thinking time, but I would also set a clear expectation that this is temporary. Degraded mode should not become the new normal. I would assign someone to work on the root cause in parallel and set a decision checkpoint. The danger is letting degraded mode quietly become permanent because it feels safer. Another one. You discover that a partial outage only affects a small percentage of users, but they are high-value customers. Fixing it risks impacting everyone. What do you do? This is where transparency matters. I would communicate clearly with leadership about the trade-off. There is no technical answer that solves the business decision for you. My recommendation would usually be to protect the majority while isolating or compensating the affected users. That could mean targeted fixes, traffic shaping, or even manual intervention. Rolling out a risky change to everyone for a small subset is rarely the right call, unless the issue is escalating fast. Let's go deeper. During a partial outage, an engineer pushes a quick fix directly to production without review. It improves things, but bypasses process. How do you respond? In the moment, I say thank you and stabilize the system. Process discussions do not belong in the heat of recovery. Afterward, I address it calmly. I want to understand why they felt bypassing process was necessary. Was the process too slow? Was ownership unclear? Was pressure mismanaged? Blame fixes nothing here. The real risk is teaching people that heroics are required. I want systems and processes that make the right action the easy action. Last pressure question. How do you know when to stop investigating and accept degraded behavior for the day? I look at three things: user impact trend, system stability trend, and team fatigue. If impact is no longer growing, the system is stable, and the team is exhausted. I pause. Pushing tired engineers into complex debugging creates new incidents. I would document what we know, set alerts, and resume with fresh eyes. Accepting temporary imperfection is sometimes the most responsible choice. That brings us to the end of this interview. Partial outages are some of the hardest situations you will face as an engineer. Nothing is fully broken. Nothing is fully working. You are constantly trading speed for safety, clarity for uncertainty, and user experience for system health. If you were watching this seriously, I hope you paused and answered each question out loud. Not to match my answers, but to hear your own thinking. That is how you get better under pressure. Which question felt the hardest to answer? Was it deciding when to declare an incident, choosing who to protect first, or knowing when to stop? Let me know in the comments. If you want more interviews like this, focused on real production judgment and not just definitions, subscribe so you do not miss the next one.